Absolute value is a very key part of Math 051, and it's even a key part of Math 020 as well. And the fact that when we're talking about absolute value, we are talking about distance from 0. So absolute value is really the distance something is from 0. When you take the absolute value of a number, you're asking how far is this number from 0? So let's look at this first example here. If I say the absolute value, and that's what these bars represent, the absolute value of negative 13, this is really just asking how many spaces is negative 13 from 0? What's the distance negative 13 is from 0? And the answer is, well, if we were to count the number of spaces between negative 13 and 0, it would be 13, a positive 13. And the reason it's positive and not negative is that we're talking about distance. And we always talk about positive distance. We never talk about negative distance. You don't say Harrisburg is negative 40 miles from here. And that's just not the way that we communicate. That's not the way that we describe distance. We always talk about the distance being positive. If you look at the next one, the absolute value of 5. Well, how far is 5 from 0? Well, if you count the blocks, it's pretty obvious that you get 5. And finally, the absolute value of negative 7.2. Well, it's going to be a positive 7.2. We never talk about distance in terms of negative numbers. So this is one important part of absolute value. When you take the absolute value of a number, you're asking how far it is from 0. What we're about to see next is what happens when you take the absolute value of a variable and you know what that is equal to. And that is a key difference here. Okay, so on that last slide, we showed that the absolute value of negative 13, when you have just a number in the absolute value, you're asked to find how far that number is from 0. So as we saw, negative 13 is 13 spaces from 0. The absolute value of a number will always be positive. Now, down here, this is a little different. You're asked, well, really what you're told is that the distance x is, and we don't know what this x is, but we know that its distance, when we counted its distance from 0, we got 10. So if I were to draw a number line, and we're looking for the solutions to this, we're looking for the numbers that have a distance, some numbers have a distance away from 0, have a distance of 10. Well, obviously, you can think about that as 10, right? One number is 10. What is easily forgotten is that negative 10 also has a positive 10 difference. So when you have the absolute value of x equal to 10, or when you have any absolute value in an equation, you have to break it into x equal to 10 and x equal to negative 10. Because when the absolute value of a variable, well, whatever is inside could be a positive number or a negative number. We have to be careful. In this example, we're asked to solve for x, and we are told that the distance 2x plus 1, the distance it is from 0, is negative 7. So this 2x plus 1, we need to have negative 7 spaces away from 0. Now, I'm going to give you a second to think about that. Why would that be a little strange to say 2x plus 1 has a distance of negative 7? Well, as we just saw, we don't have or talk about distance being negative. So, 2x plus 1 can never be negative 7 spaces from 0. And the reason why is we don't talk about negative distance. So this answer right here would be no solution. The absolute value of this can never, whatever we plug in for x, whatever we plug inside here, once we take the absolute value of it, it's going to become positive because we're finding the distance. So this will never be a negative number. Let's do one more example. Our final example tells us 3 times the absolute value of x minus 2 minus 7 equal to negative 1. Now, once you look at this, according to our last slide, we never want an absolute value to be equal to a negative number. But before you determine whether or not there are solutions or no solutions, you have to first, and you must do this, you must get the absolute value by itself first. Yes, we look over here and we have a negative number, but that doesn't mean we can immediately jump to the conclusion saying that there's no solution. We have to first isolate this absolute value. So we're going to isolate this. The way I like to think of it, this is almost like a little house here. It's almost like a little house that we have to get away. We're looking to tear down the walls of those absolute value. But before we do that, we have people on the outside. We have 3. We have 7. We need to get rid of them before we tear down this house. Move the women and children away from the building before tearing down the house. So I'm going to rewrite this because my illustration there is taking up some space. So we get, once I rewrite it, let's add a 7 to both sides. And then we have 3 times the absolute value of x minus 2 equal to 6. We can divide both sides by 3, and look what happens. When we isolate the absolute value, it's equal to a positive number. So really we're okay. Now we're told that the distance x minus 2, its distance from 0 is equal to 2. So in order to solve this, we have to set up our 2 equations. X minus 2, if it's 2 spaces away, that means it could be at 2, or x minus 2 could be at negative 2. So when I solve this for x, I get x equal to 0. And over here, when I solve this for x, I get x equal to 4. So these, x equal to 4 and x equal to 0, are 2 solutions that satisfy my original equation.